So in the previous video we have done with definition and operations of queue, and then we have written a program using array and executed also. Now we'll go for the same the concept of queue operations using linked list, and we'll execute. Hello everyone, this is Shravan Kumar Manthri. Welcome to our channel CSE Gurus. So for this, when you write with the linked list, each and every element, let us suppose I want to insert the elements into the queue. For example, the elements are like this. If I give something like 5, then 10, something like 15, then you have to arrange in terms of the linked list, which is as a list of elements which you can make the nodes like this. So nodes like this. So if it is 3 elements, yes, 3 nodes are required. Here 5, this is 10, this is 15. Of course it's the last node null, and of course the first node where it is starting with 5, that's why head, which is head node, we call it as. So here the address, let us suppose it is 100, here it is 100, it is connected. Let us suppose this is 200, this here the address should be 200, it is connected. Assume that this is 300, means here it should be 300. That means these 3 are connected, which is the arrangement of queue like this you will have in a linked list. Now what are the things you need to observe with respect to the linked list in order to make it? So first thing, what is the enqueue operation? Enqueue in the sense you want to insert an element into the queue. Where you can insert, let us suppose 20 to be inserted after 15. That means indirectly, can I say in the linked list you are inserting a node which is 20 at the last, right? So can I say this is what the concept of inserting node at the end in a linked list. So enqueue in the sense, enqueue in a linked list in the sense inserting node at the end. Now what about dequeue? Means deleting the node in the queue, deleting the element in the queue. So if this is a linked list, if this is a queue, 5 to be deleted first. So that means first element. So deleting the element in the queue means deleting a node at the beginning, not at the ending. So this is the one thing you need to remember, deleting the node at the beginning, what you need to do. And third one, what is a front element? What is the front element? Let us suppose if I have like this 5 here, it is there. So front element means first element, which is the first node, which is a head node, address of the head node, the value inside the head node. Of course you can have is empty, means the list is empty, linked list is empty. Of course there is no constraint for is full. Why? Because you are supplying the, linked list means you are dynamically creating the memory. So these are the things you need to keep it in your mind, and we'll try to implement this from a scratch. So hash include, I'm writing the code. So I think if you want to have a clear picture of how to insert the node at the beginning, at the end, how to make it in the linked list, I explained clearly about linked list concept. You can watch my previous videos about single linked lists. So here first thing I need to create a node, struct node, which consists 2 parts. One is data part and the other one is structure, of course node, which is a self-referential structure, which is next. So if I write like this, what happens initially? So now if I write like this, a node will be created like this. So node might consist the data part and address part like this. So you just declared, not yet exactly created. Now I want to create the starting point, which is a head node, where the head node address is stored, which is called as the first node in the linked list, which is the first, of course which is the node first in the front of the queue. Head, which is anyway initially no nodes are there, which is null, you can make it. Now you need to start the process of what you call as void main, where the options to be given. Simply same thing, like I need to create a choice and I want to write here the options. You can see all the options, asking the user printf, of course, yeah, enter choice, enter your choice. So choice from the user I'll consider. So here we are writing the first one, enter your choice. So user choice we are taking. So what are the choices user have? I'll write it here. So first one is what he wants to do, enqueue. So here we have written the choices. You can see NQ, DQ, front. What is the front element? Exit. Then is empty. You are checking is full. Of course, is full is not required here. So option 6 only we have to write. So the display part we made it. Of course, I'll write here like this. So like this we have options. Then we want to ask the user to give the inputs. So user is giving the option, and then so here we have written the cases. You can see. So here we have written the cases. Case 1 to enter the value to insert. So value to be inserted, of course value to be declared here. So the function to be executed is NQ. I'll write that function. Next DQ, deleting from the queue, then printf what is the front element, then exit, then like this. Of course, why we have written exit means, so this part has to be, everything has to be executed infinite times, these options to give until you go for exit. So I'll write file 1 here. So it has to be closed here. So this is closed, this is main function closed. So what we have done as of now, simply created a node for the structure, then head equals null initially. What is head equals null means here like this. So this head node is null initially, so that's why nothing is connected. So now we'll start the process of NQ. We'll write the function for NQ. So we are writing NQ where I have taken the X value, input value, that value, let us suppose 5, to be inserted into that. So what first we need to do, we need to create a node. So with respect to the self-referential structure, this is a node, and for this I need to give the value and then null, that needs to be done here. So how to make it, we can see. So this is what to be done initially. So here I'm writing. So first I need to create a node, struct node, where node name is nm, which is a new node I'm creating. What is nn? I want to allocate the memory dynamically. malloc of how much size is required? Size of that structure, right? So size of struct node, how much it is needed? Actually that much you need to get it. Actually how much it is needed? One is for data part, integer, other one is for address part. Of course that is also an integer. So might be 8 bytes are needed, 4 plus 4. So but you need to make it typecasting how that memory, let us suppose memory starts from 100, it will take 100 to 107. So totally 8 bytes like this. Once you create the memory, what is the value inside this? nn of data, you have to give it as x value. What is x is given? What is nn of next, which is null. So when you write like this, what happens is, here what you have written here, so this is what happens. So 5 null will be taken first. Now this 5 and null to be connected to the queue, right? So you have to connect it. How to connect it? So you can connect head node is null, that's why you need to connect this value. Now the things are there where you need to take two values. I told you like front is there, rear is there. Okay, till now we didn't take what is front and what is rear, right? So we need two values, right? So front and rear instead of course head in the sense which is front, right? Same thing here happens. So that's why instead of writing here as head node, I'll little bit change it here as, in the head node I'll write it as front. Anyway, front in the sense first node in the linked list, and I'll write rear. So to make it better terminology, so rear is also null. So front and rear both are null initially, that you are making here, and NQ is over here. Now you are checking. So what is the first thing? First thing you need to check it out, is that queue is empty. How can you say that queue is empty? So that means your front node value will be null, right? So that is what here. So this is, of course, this is a front node, which is equals to null. Of course front and rear, anyone is null, then you can say that queue is empty. So that's what I'm checking first. If front is equals to, it's a pointer, right? That's why if front is equals null, so what you need to do, queue is empty. Now you need to insert our node, right? So we need to insert our node. So front equals to null. What you need to do here is, it's something like insert node at the end. What you need to do, okay, of course The first thing is, if front is equals to null or rear is equals to null, you insert the node first. So that means front is equals to rear is equals to that node. What is the node name? NN. So now what happens when you write like this? So here this NN will be connected 100. So now when you connect it, this is 100 here. So now that front will be 100 here. Of course rear also this one. Initially both are null, right? So now front and rear both are here. This is connected. Only one element is there. I'll try to write it again. So now the queue will be like this. Anyway, I'll write it here. When you arrange like this, front will be here 5. Of course rear also here. Why? Because only one element. Previously there are no elements. That's why front is null, rear is null. So you insert it. Now if it is not null, if rear is not null or front is not null, what you need to do? So you need to just insert at the end, right? So you just insert at the end. That means you go to the rear, you go to the rear. That means, let us suppose I'll insert one more element here. I need to insert, right? So what is rear? What is rear here? Here you have rear. So let us suppose I want to insert a node called as 10, like this, 10 and null. This is NN now. Anyway, this is not NN now. This is not NN now. It's already is there, let us suppose. Now I want to insert this node 10 and null. How to insert? What is rear here? Null. This has to become your present value. So rear of next should become your NN. So this address, let us suppose this address is 200. So here it should be 200. So here it should be 200, the value, and after that your rear has to move here, right? Front will be here only, but rear has to move here. So 2 points you need to remember. One is rear of next, which has to be updated to your NN, and rear has to update to NN also. What is the rear? Is also updated. Now you can see rear is here, okay, front is here only, connected. You can connect like this. So else part I am writing here. So I am writing else part. Here we are writing. So the point number 1 is, what is rear of next? Only rear of next is equals to the given 1, which is the node, and what is the rear to be now updated to NN. Like this we can write. So rear is now updated to NN. So 2 statements are enough. I think this will be inserted. Now let us suppose if you insert, that is 10 is inserted here. Now let us suppose I want to insert 15. So 15 you want to insert, this is NN. So this is not NN now. So where is rear now? So rear is here. Now rear has to move. Rear of next, what is that? Null. Now it has to change 300, let us suppose. So you can see rear of next equals 10 and 300, and now rear from here to here it will go. So 15 is inserted into the queue. So like this you have to do step by step the operations very easily. Of course this is about NQ. Simply if it is front is null, list is empty, queue is empty, front and rear equals the current node. If not, you have to make like this. Now the second function DQ, we'll try to write what is DQ, deleting the node. So void DQ the elements which is the front, then only that has to be deleted. Now DQ, I told you, deleting the elements means deleting at the beginning, right? What is the front element? That is only you have to delete. So for this also you observe what we need to write. So what is that front? So let us suppose I want to delete front, means 5 will be deleted. Deleting the queue means first will be. So this entire has to be deleted, means the connection should establish like this address also to change. So 2 things. One is your front has to update to front of next. What is front here? 100 to the next 200. So front equals to front of next has to be done. Then anyway front has to be updated. Then this part has to be deleted. So for that I am writing here, you can see. So and one more thing. Anyway, first I'll take a struct node. I'll tell you why should I take a pointer temp. Anyway, when you delete, rear is not updated. You can see in some cases, only one case rear has to be updated. I'll tell you which case. Temp equals to, which is starting from the front first. Okay. So of course I don't want to write the loop, actually I want to store it. I'll tell you now. Here also the same situation, like what if it is only one node? So if it is more than one, friend will be updated. What if it is front and rear, both are only one node? What you have to do? You have to delete this and you have to keep entire queue is empty, right? So if only one node is there, assume that only 5, so queue has to be empty, right? So we have done in arrays like f equals to r equals -1. Similarly here also you need to do. If there is a one node, how can you know that there is a one node? Means front double equals to rear, both addresses are same, means what? So only one node is there in the queue, so that means one node in the linked list. So you can make it like, if there is only one node in the linked list, of course before that you might have one more thing also. What is that? If the queue is already empty, that I'll write first. So what is that? First, if front is equals to null, right? If front is equals null, queue is empty, right? You cannot delete, right? So that is, I'll write here, queue is empty. Queue is empty. Now else if, you can see the conditions, else if, now I am writing only one node is there, front is equals to rear. Now what you need to do, you have to make it front equals rear, means you have to delete that. Anyway, front is equals to rear is equals to null, both has to null. Why? Because queue is empty. Now what is you have deleted? A node, right? 100 is a node value. How can you delete? Of course it's a dynamic memory allocation, you have to delete that space also. So for that I stored the front value in the temp. So now I'll write here, which is deleted from the queue. I'll write here printf %d deleted, which is the front of the queue, which is temp of data. I can write, don't write front of the data. Why? Because front is updated. Of course you can free the memory free of temp. This is the one thing you can do if only one node is there. Else if you have more than one, means in general only front has to be updated, deleting node at the beginning. I think you can write like, what is the statement I told you? Front equals to front of next. So this is the statement you can write, front equals to front of next, directly connected. That is, this node will be removed. That means front is directly to here, with this front will be here, right? So and of course you can write what is deleted, first element. You can write the same statements here also. Now this is simply about deleting the node in the queue. Now the next one to print what is the front of the front element. Definitely we can say that first element. Front means head node or first node. So simply you can print it, and of course you can write this statement also. Of course, what is that? It needs to return. So int front. Of course, what you need to return what is the front, which is front of data. But the thing is, what if the list is already empty? That you need to write here. If, how can you say that? Front is equals to null. If front is equals to null, as you can see, printf queue is empty. Of course directly, no need to, no front element is there. So else you can return. Of course you need to return, right? That's why you need to write a queue is empty and you return -1, something you are returning. Else you need to return front of data. That's it. That is front. Now do you want to check it out is empty? Yes, you can check it out is empty function. So which returns, so we are writing is empty function, int is empty. So how can you say that is empty? So very easy one this is. So checking if front is equals null or rear is equals null, anyone. So return 1, else return 0. So that's it. Easily you can write it regarding this. So that's what we have done as of now. Let us clear this one. We'll try to get the output for this. We'll see whatever we have written, whether any errors are there. First of all, check it out. After that, we'll see the outputs. Yeah, the problem here is friend is a variable, it is declared, and friend has also function. So that's why I'll write it as, rename it as friend element. So same name is not allowed for the function as well as a variable. So friend element I'm writing here also. Now you can see friend element. Yeah, one more thing we forgot to implement. What is it? Display, which is case 6, which is display not yet been done. So we want to display each and everything, which is simple one. I'm displaying here, starting from the head node, that is a friend, to the rear. We have to display it. I'll write here display. So these are the connections. Let us suppose our queue consists, these are the elements 10, 20, 30. Where is front? Here front, this is rear. Now I want to display all the elements. So for this I'm writing here, I need a temporary variable, struct node, a temporary variable which has to start from the first node, which is friend node, and now it is going step by step. You can see, of course we'll write a first thing, if this part, if front is equals null, immediately you have to write queue is empty, right? So nothing to display. So I'll write if front is equals null, as queue is empty, else you want to go for it. So we need to write a loop to get each and everything. While, so till what you need to go? While your temp should reach, see, if I write temp is not equals to rear, or temp what you call as, I'll take temp is not equals to rear. Temp is moving step by step. Temp starts here. Okay, temp starts here, it prints 10, then temp goes here, it prints from temp goes here. But if I write temp not equals to rear, means it will skip the last one, right? So that is not correct, and you have to write while temp is not equals to null. That is absolutely fine, right? So while temp is not equals to null, I want to printf %ld, what is that element? That is temp of data. Then temp has to move to the next, which is temp equals to temp of next. Similarly, we'll write in general arrays temp I++, right? So when temp is null, then it comes out. That means all the elements will read it. So this is what we have written, and still we'll check it out. Any errors, anything? Absolutely fine as of now. We'll go for option 6, display, queue is empty. Okay, what is 5? Option 5, is it empty? Yes, true. 1, fine. What is the front element? Nothing is there. Queue is empty, fine. Now we'll go for NQ. I'll enter 10. Again NQ, I'll enter 20. Again 1, I'll enter 30. 3 elements. Let us see the display part. So 10, 20, 30 in the queue. One more element, why not? 40. 10, 20, 30, 40. Now go for DQ, which has to be deleted. 10 has to be deleted. So 10 deleted. See the display, 20, 30, 40. Perfectly fine. Now you see the front element. What is the front element? 20. Yes, 20. You delete one more, DQ. So the display is like this. What is the front element? 30. You want to insert? Yes. You can insert 25 at the end. Yes. 25 will be at the end, right? So you see the display 30, 40, 25. So like this, if you want to delete, yes, you can delete. 30 will be deleted. So that front element is 40. Again you can delete. That is 40 will be deleted, first element. So 25 only is there. Still you can delete. Yes. Or else can you get the front element? Yes, which is 25. Now can you delete that? Yes, DQ, 25 is deleted. You see the display now, which is queue is empty. Now still if you want to delete, it says queue is empty, right, which is an underflow condition. So like this easily you can consider how to make it, how to get the answers, how to write a program for queue operations by using linked list. So once again I'm writing here, you can see the shortcuts for this where connected with linked list and queue. So enqueue operation means insert node at beginning. Enqueue operation, which is insert node at rear at the last. Okay, insert at end. Now dequeue means delete node at beginning, right? Now if you want to get front element, simply what is the front or first element or head node, and of course if you want to get rear, directly you can get rear of data directly. So these are the things you need to observe, might be the shortcuts you need to remember for the interview purpose. So I'm showing the entire code. Those who are executing, they can check it out clearly. They did make any mistakes, they can check it out for errors. Clearly check it out and write the code and execute. Now we'll see about complexity of these programs using arrays and linked list. So first we have written the code for queue with respect to array. Okay, so I'll take like this. What are the operations we have done actually? Insert operation, which is enqueue, right? So I'll write enqueue operation, then dequeue, of course finding what is the front, mainly these are the things, right? So of course is empty is fine, is full is fine. Okay, so all these three operations with respect to array, what is the complexity? With respect to linked list, what is the complexity? If you see here, we have written enqueue program. Is there simple if conditions, else part there is no loop, simply it's a constant complexity which is big of 1. Now even if you can see here, deleting the elements, there is no loop here also, which is also 1. Now of course one more thing, we need to write display part, the function display. Now front, getting the front, of course display part you can see, yes, you need a loop here, you can see for int I. Why? Because in the case of, for example, if the size of the queue is full, there are n elements, then definitely you need to traverse this loop n times. So that's why in the worst case it is n complexity display. Now how to get the front? Simple condition, right? No loop, nothing. So this is constant. So I'm not saying here if there is a loop then the complexity is n. I'm not saying, it varies actually, but if there is no loop, simple condition means definitely it's a constant complexity. Now coming to the linked list, if you see the linked list programs, we have written here and enqueue program inserting. So here you can see if condition, simply in the enqueue, else part, that's it. Very simple, we have written the constant complexity 1, and dequeue here also you can see. Anyway, we maintain the rear node, right? So we maintain the rear node always, that's why the complexity is 1. But if you don't maintain the rear node, then definitely it will be n complexity. So that is the thing, maintaining the rear node. Why? Because you need to traverse till the last, right? Of course for inserting actually, for inserting the elements into the linked list, okay, where it has to insert at the end, that's why the complexity will become n if you don't maintain rear node. Whereas deleting, anyway it's absolutely fine, even if you don't maintain the rear also, you can get 1 complexity only. Okay, for this if you don't maintain enqueue, for this it is n complexity if you don't maintain the rear node. So now we maintain, that's why it's constant. Now front element, only condition you have written, the complexity is 1, and of course the display part, finally you can see the display part here, we have written a while loop. So where it has to traverse, your temp has to traverse. If there are n elements, it definitely has to traverse for n elements. So that's why the complexity is n. So this is what you can do with respect to the complexity part with respect to queues, with respect to arrays as well as linked lists. So we'll see next what about circular queue, how it is different from the queue. We'll see in the next video lectures. Thank you.